Hi everyone, so today I will be teaching you guys how to integrate this function with limits, and here are the steps for integration. And the first step is to find delta x, which equals b minus a over n, and in our case it would be b minus a over n. And then the second step is to find xi, which equals a plus delta x times I. And I will show you guys how to do that in a few moments. And then the third step is to write everything as a limit with the summation notation, and you will also see that in a few moments when we actually try doing an example of the problem. And then we need to plug in xi for every time that there is an x and multiply everything by delta x. And then you just need to simplify it even more so it's easier to solve and find the integration of. And then you have to plug in the I values, and I will show you those in a few moments. And then you need to simplify even more than before because it just makes everything easier to integrate and solve for. And then finally, we get to find the limit to infinity. And here are the various I values that you will need to memorize for upcoming tests or quizzes, because these are just things that you need to use every time that you integrate with limits. And integrating with limits is considered the long way of integration. So now we can start doing the integration. And we start with finding delta x. So delta x equals 3 minus 0 over n, which equals 3 over n. And we see that because it's 3 minus 0 over n, which equals 3 over n. And then now we can find xi, which equals 0 plus 3i over n. And as we can see, it matches with what our equation is, which is a plus delta x times I, which equals 3i over n. So now that we've had these beginning functions, we can now put everything as a limit. So we have limit of n to infinity of summation. And here is the summation that we need to use for every type of these problems. And as I said before, now we plug in xi for every time we have an x. So we have 3i over n plus 4 times 3i over n squared. And then you need to multiply everything by delta x, which is 3 over n. And now that we have that, we can now simplify it even more. And so we do limit n towards infinity. And the reason that you do limit of n towards infinity, because if you think about it, n is the number of rectangles that you have technically, and if you have an infinite number of rectangles, that means that is the most accurate Riemann sum, or the most accurate area under the curve, and that's what an integral is. And now we can move the delta x over here before the summation, because we don't have to worry about that until the very end, and then that's when we have to multiply in, but for now we don't have to do anything. So you can just move that right here and then continue the summation, and then just start simplifying it a little bit. Plus 4 times 9i squared over n squared. And this is just more simplified version of this. And now we can actually start doing the summation and simplify. So we still have the limit, and we always need to write these limits and summations until we've actually done them or solved it, and then we don't have to keep writing them anymore. But for now, we still have to keep writing the limit. So once again, we keep the delta x at the beginning because that doesn't matter until the end. And then for the summation and integration, we need to plug in whatever I values that we have. So in our case, it's I and I squared. So this is how you will do them. And these are just the I values I showed you guys earlier. and this is the I value. So these are the two I values, and the 36 over n squared is just a more simplified version of 4 times 9 over n squared, and then we can take the I squared out and multiply everything by this because it is that, and we can take out the summation because that is just what we've done by plugging in the I values. And now we can continue and do the limit of n towards infinity, 3 over n. As I said before, it's the same thing. And now we can just simplify even more. And these n's cancel out, so you have this, because if these cancel out, it's just this times n plus 1 over 2. And then you can see that the 6 and 36 cancel out, as in this turns into 6 and this turns to 1, so this is a 6 right there. So it's just even more simplifying. And then you can also simplify this by multiplying it out and getting this 2n cubed plus 3n squared plus n. And then you have to put everything over n squared once again. And now we can do even more simplifying once again and keep multiplying everything together to make simpler terms. And you can do 3n plus 3 over 2 plus 12n cubed plus 18n squared plus 6n. And this is just multiplying the 6 into all these values and then putting it all over n squared. And then we can simplify this part and this part even more, and the reason that we have to do that is to make it easier to multiply the delta x into each individual section. Now that you have that, you can now simplify it and finally do the limit portion of what you have. So you can do 9 over 2 plus 9 over 2n plus 36 plus 54 over n plus 18 over n squared. And this is just delta x, which is 3 over n, multiplied into each individual variable or each individual section of the problem or the equation in the parentheses. And this is what you get from that. And now we can start doing the limit portion of that, because we know that every time there is a n in the denominator where it goes to infinity, that will have to equal 0, because if you think about it, a number divided by infinity will equal 0 or will approach 0, because that is the largest number possible or impossible. So all of these will go to 0, and you end up with 9 over 2 plus 36, which in turn equals 4.5 plus 36, which equals 40.5. And this is the longest way, or the longer way, of doing this type of problem or integrating. And you can also check the answer that you get here with a graphing calculator or also the multiplication rule.